All right, guys, welcome back. So sorry for no video um, at the beginning or the end of last week. I'm getting over the coof. Yeah, I finally caught the damn thing, and man, it was rough. It was rough, but I seem to be past it. So at last we left, I made this this mount and this slide so that I could put something on. I've since then made this coil holder, which slides back and forth. So this can slide back and forth so I can move the coil in and out. It's made with all 3D printed parts except for the plexiglass. But yeah, this is from a clamp. I just cut off. It's a 3D printed clamp. I just cut off um, uh, the end part, and then just 3D printed these guys here. So this will be good. I can put a coil in there, and I can, mount this base to something. I'm not really sure how I'm going to do that yet. I left it loose like this so that I can just. This is a little too tight, but that's actually kind of good. So I can move the coil in and out. I've also printed out a new a new rotor for my maglev. In talking with Sky, he discovered that having 4 poles, especially ones that are really powerful, N45s or N52s, having the 4 poles caused interference. The magnetic flux was all over the place. And so I 3D printed a new one here with just the 2 poles, and I'll set that up. And I'm also going to use this non-magnetic stainless steel I'm going to sharpen this on a grinder. And I printed out some of these. Where are they? So I'm actually going to use this guy, which is bigger. And then this guy's going to go inside of it. And these end caps are going to hold, where is it? I'm going to be using these much bigger magnets for the oh, that's the wrong one. For the uh, I'm still a little foggy from the coof. For the center rod, or for the rod magnets versus the ring magnets that are in the housing on the other setup. Anyway, yeah. So he discovered, and he said, yeah, that he figured out that it causes a lot of issues to have the 4 poles, especially when they're as powerful as magnets I have. Oops. So yeah. Oh, what happened to it? God damn it. Anyway, yeah, I'm still recovering. It was rough, man. Let me tell you. Ooh la la. I don't ever have to go through that again. And it was funny because I caught it from my wife, who caught it from some place up there in Grass Valley here in California. She was up there, and she's really careful. I mean, super paranoid careful. I don't know how she caught it. But anyway, my kid didn't get it, which was great. He had gotten it earlier on, like in 2020, I think. But he was asymptomatic. He had like almost no symptoms. Me and her were down for the count, but we're doing okay now. And hopefully I can get back to building. So yeah, it'll go in like this, right? It'll clamp down like that and hold it so that I don't have to hot glue my coils to the bases anytime I want to do something. And then this can go in and out. And then the whole thing can move in and out. Well, the whole thing can move, but then this can slide in and out for a more precise thing. Came out pretty good. I really like the way it came out. Nice and sturdy. Yeah, so what else? Oh, I talked about this guy for the maglev. And what else? I think I'm going to be trying to wind a new coil. I think there's something wrong with this guy. I haven't really checked it out yet. But this is my big coil. Oh yeah, and Sky also told me not to use that smaller coil that I've been using to test on these, especially on the maglev. He said it's not powerful enough, and he's right. I was just using it to test. And I have other coils that are much bigger. Like I have this monster right here that has 3 wires on it. I could always use this guy. This is really heavy too. And then I have a bunch of other coils. I've got this guy here, which is really cool. This is a bifilar. I've got a bunch of coils that I've made. But anyway, once I'm feeling a little bit better, I'll get back to testing. I definitely want to test this whole setup here. And I think I'm going to test it with different circuits. Like I've got the Bedini circuit, this guy here, which is really cool, that I think I want to test this with. And of course, I'll test it with the JL94, and then I'll test it with the Hall sensor. But yeah, I wanted to show you this guy, and this guy, which I just finished. And yeah, it should work out pretty good. All right, stay tuned. All right, so let me show you how this is going to work. So obviously this is going to be the main shaft, which will go inside here, right? Then a smaller carbon fiber rod goes in there. Then I have a cap which has an indent, so when I put it here, it slides down there, but then it captures this end right here. And then this guy will go on there, and then this one has no capture area. And then this is going to be ground to a point. So this is going to be the new shaft magnet for the maglev. And I measured, and the 2 magnets that I have in the ring are the same width as this. So that's perfect. So this will go in. This will be sitting up. I'll either make this longer or shorter, depends. And this is non-magnetic stainless steel. And of course, this is all press fit, but it'll be probably glued. But yeah, this is going to be a really cool way to do it. And I'm also going to make sure that I leave enough room. Oh, that's also what I wanted to talk to you guys about. What did I do with it? I got myself, I don't know if I brought it out here. What did I do with it? It must still be in the house. I didn't bring it out here. I got myself some MU metal, which is the same metal that they use in hard drives to stop the magnetic flux from going outside of the hard drive cabinet. It's a metal. I don't know how it's made, but it stops magnetic flux. And Sky was telling me, and I didn't realize that he actually used hard drive MU metal, MU metal from hard drives in the end of his rotor to stop the magnetic flux from hitting the ring magnet. So I'll probably incorporate something like that to help myself so I don't have to make the shaft so long. I got the MU metal in sheets, and they're thin sheets. I'll have to do some tests to see how much of the magnetic field or the flux it'll actually stop. So I may have to double up or triple up or even quad up on it. But I'm sure it'll help no matter what. So yeah, that's going to be cool. But I think this is going to work really well. Because unfortunately, I don't have the materials to make a stainless steel non-magnetic shaft with press fit copper washers on there to hold the magnets on there. I have to do it what I have, and the best way I can do it is brass is too soft. So the best way I can do it is with these carbon fiber rods, and they seem to work really well. So yeah, I think that's going to work out really good. Anyway, stay tuned.